Okay, we're going to have a look at CisTrans isomers, and first of all we're going to have a look at a very simple example of one alkene which can display CisTrans isomerization. This molecule is based on ethene because we've got two carbons here, and there's your carbon-carbon double bond. We've got dichloro, ethene, but the chlorines are on carbon number 1 and carbon number 2, so we need to call that 1,2-dichloroethene. That's an E there. If I select this and paste it over here, but what I'm going to do now is swap these two over. So I'm going to call this one, oops, I'm going to put a chlorine here and a H here. You should see that that is also 1, 2 dichloro. There's a chlorine on carbon number 1 and a chlorine on carbon number 2, dichloroethene. Now the reason we call it CisTrans is because if we draw an imaginary line here and here, you'll find that over here the chlorines are both on the same side as this of this line, and the chlorines here are on opposite side. So this one here would be the cis isomer because they're on the same side, and this would be the trans isomer. So the left hand one is cis 1,2-dichloroethene, the right hand one is trans 1,2-dichloroethene. Now that's all very well when we've got a relatively simple alkene. Let's have a look at a slightly more complex compound, and that will take us on to ZE. Okay, so we're starting with the same basic alkene structure, and I'm going to look at 4 different constituents here: H, Cl, and Br, and F. So this would be called 1-bromo, 2-chloro, 1-fluoroethene. It's done in alphabetical order: B, C, followed by F. Bromine is on carbon number 1, chlorine is on carbon number 2, and fluorine is on carbon number 1. If we were to swap these two around, would that make something new? The answer is yes, because remember we've got restricted rotation around this. So let me just select all that again and put it over here. But like I say, what I'm going to do is swap these two round. So I'm going to take a fluorine and put it here, and a bromine and put it here. They're both still clearly 1-bromo, 2-chloro, 1-fluoroethene, but they are both clearly different. And we can't use the cis and trans because we don't have the same functional group here and here. So we need to use a new way of naming those compounds. So what we now do is we look on one side of the molecule. Let's look on the left hand side, and on the left hand side we're going to star the one that's the biggest, the one that's got the biggest relative molecular mass, and it's the chlorine. If we do the same on the right hand side, we're going to star this one because bromine is bigger than fluorine. Let's do the same for this molecule here. On the left hand side, which is the bigger out of chlorine and hydrogen? It's obviously chlorine. And on the right hand side, which is the bigger? It's bromine, out of bromine and fluorine. And that way we can work out whether it's Z and E. Over here you'll see that the biggest one is on opposite sides of the carbon-carbon double bond, and over here you can see that the biggest ones are on the same side, the Z same side. So we end up saying that this here is the E isomer, and this one here is the Z isomer. So the left hand one would be called E, 1-bromo, 2-chloro, 1-fluoroethene, and the right hand one would be called Z, 1-bromo, 2-chloro, 1-fluoroethene. Hope that makes sense.